Hi, friends. A common question from students is, how do I relate the instructions on a problem to what I'm supposed to do? So I have two videos I want to direct you to. One is the directions say simplify, and the other one is the directions say solve. Today we're going to talk about when your directions say simplify, what does that mean? You might see this as the whole instructions say simplify. The other thing you might see is the instructions say to do something and then make sure your answer is fully simplified. So I'm going to speak to both of those things today. All right, so when the directions say simplify, that means that we are not going to change the value. Okay, so we are not changing it. We're not changing the value, just what it looks like. So a very small example would be, instead of 3 out of 6, we are going to simplify that to its simpler form of 1/2. This would be the simplified answer, where 3/6 is correct technically. If it was asked to be in its simplest form or to be simplified, 1/2 is our correct answer. So we always want to be looking, can my answer be simplified? Because it is no fun to lose a point on a correct answer that wasn't simplified. So I want you to really be comfortable with simplifying. All right, so some things that we might do to simplify. Number one is we might combine like terms. So that would mean that all the x's are together, all the x squareds are together, all the numbers got combined together. Another one that's super important is reduce the fractions. And that applies to not only numerical fractions like I had up here, but also variables. So I'm just going to make a note, numbers and variables. Okay. Another way that we might simplify is using our distributive property to remove parentheses. Parentheses always looks like it has too many letters. That's correct, though. All right, and then the last one I want to point out is to do any operation. So this might be writing 2 squared as 4. We wouldn't want to leave a 2 squared in our answer. We would want to write it as 4. Or it might mean, instead of writing square root of 16, we want to write that as 4. If you have a 4-year-old kid, you wouldn't say, this is my child, they are square root of 16 years old. That would be silly. We would say they were 4 years old. All right, so those are our main things that we're going to be looking for when we want to simplify our answer. So let's see. Let's look at some examples. All right, so the first one, I'm going to write 2x times x plus 1 minus 3x times 4x. Oh, and I had a little bit more on there. We're going to do a whole long problem here. Plus 2x plus 1 times x minus 3. Okay, if we wanted to simplify this, that means that we're going to distribute to remove those parentheses. We're going to collect up any like terms, And we're going to do any multiplication involved here. We want everything to be as worked out as we possibly can. All right, so first thing, I have 2x times parentheses x plus 1. I'm going to use my distributive property to rewrite that as 2x squared plus 2x. Next thing I have is minus 3x times 4x. That one is not distributive property because there's no addition or subtraction. It's just plain old multiplication. So this would be minus 3 times 4 is 12. X times x is x squared. And then last, I have two binomials in parentheses multiplied together. So we're going to use the FOIL method to multiply this out. So first terms together, 2x times x to give me 2x squared. Outside terms together, 2x times minus 3 is minus 6x. Inside terms together, 1 and x gives me a plus x. And then last terms together, positive 1 and negative 3 multiplied together gives me minus 3. All right, we did the distributive property and the multiplication. Now we're going to collect up like terms. So I'm going to go through and find all of my x squared terms. I have a 2x squared, a minus 12x squared, and a plus 2x squared. So that would give me 2x squared minus 12x squared is minus 10x squared, plus 2x squared would give me minus 8x squared. I'm going to switch colors for the x's. So for the x terms, I have a plus 2x, minus 6x, and plus x. So 2x minus 6x is negative 4x, plus x is minus 3x. All right, and then last I have just this minus 3 on the end. It doesn't have any like terms, so we will just write it down. The simplified form of my original problem would be minus 8x squared minus 3x minus 3. All right, let's look at another one. What if I have, let's do 1/2 times parentheses 4x squared minus 8x, and we want to simplify it. First, we would distribute that 1/2 into the parentheses. So 1/2 times 4x squared would be, let's see, I'm going to write that a little bit different. I'm going to write it as 4 over 2 x squared. And then 1/2 times minus 8x would be minus 8 over 2x. Now you might wonder why I wrote it that way. That's to make the point that we do need to reduce our fractions. If this weren't a 1/2 that was so easy to see, it might be more difficult to remember that we have to reduce that fraction. All right, so I have 4 over 2x squared. I'm going to rewrite that as 2x squared minus 8 over 2x would just be 4x. But we would never want to leave an answer with a 4 over 2 in it. We would want to switch it to a 2x squared. All right, one more example. If I had a 5x squared y minus 10x, and I'm going to divide that whole thing by 2x. All right, simplifying this is going to mean that we're going to distribute and also reduce our fractions. So remember, distributive property not only works for multiplication, it works for division. So we would rewrite this as 5x squared y over 2x minus 10x over 2x. So we did the first step, but there's still more to go. So this first term, 5 over 2, doesn't reduce. X squared over x, though, does. So I could rewrite this as 5 over 2 times x squared divided by x would just be an x. And then the y stays on the end because there's nothing to cancel that y with. Then we're going to subtract 10x over 2x. Well, 10 divided by 2 is 5. X over x is just 1. We don't write that 1, but we do not write an x because they have canceled. So my final answer here would be 5/2 xy minus 5. All right, this is an important skill that will take you all the way through college algebra or contemporary math, whichever one you're in. And just remember, always look to see if your answer can be simplified. And at the end of a test, always look back through your test to make sure everything is simplified so you don't lose any points.